This workshop deals with the role of carbon taxes for climate change policies. Carbon taxes are a preferred policy instrument for economists due to their efficiency to achieve the predetermined goals. However, the applications have been scarce. In this workshop, we deal with an enumeration of these applications, with a study of their effects, both with methods and the data available, and also with their role in green tax reforms. The second part of the workshop focuses on the limitations to carbon taxes, especially from a competitiveness point of view and also on the distributional constraints. We gathered a group of experts coming from academia, policy making. In the following video, you will hear some of the participants' highlights in this workshop.
The climate negotiations are now entering a really crucial phase, and it's very promising to see the announcement that has come from the US government jointly with China that they want really to step up their efforts that there can be a climate deal in Paris. Having said that, we must also add that in Europe we have had for a long time a price on carbon, and we are very keen to promote an efficient policy to reduce carbon emissions. And we are in a situation that we cannot go on to price carbon in Europe if this doesn't happen with our major trading partners. So we might have to consider also introducing climate tolls for partners that will not join a climate agreement, that will not take stronger commitments to control their carbon emissions. We've seen that happen already for aviation, and it may also happen for other sectors in the future to come.
My presentation had three parts. First, how to design carbon taxes in practice, and what is the relationship of a carbon tax with other existing energy taxes or with tax reform processes. Second, how many carbon taxes do actually exist in the world today? How are they? And three, how to assess these actual applications of carbon taxes. My conclusions were also limited. First, these taxes are possible. I mean, they can be implemented in practice easily. Second, the number of applications is scarce, of carbon taxes, I mean, but not of energy taxes. And energy taxes have important side effects in terms of greenhouse gas emissions. Overall, however, the amount of academic literature on the assessment of both energy and carbon taxes is still limited.
Oh, hi, I'm Susanne Akerfeldt. I work at the Swedish Ministry of Finance in Stockholm, and I've been doing a presentation today about the past 20 years of experience in Sweden of the carbon taxation and environmental taxation. And we have seen very good results, and the GDP has increased while the emissions have been reduced, and we have seen a decoupling of those. So we see very good results, and the CO2 tax is a very good instrument to fight climate change.
So I'm talking about the experience with the Dutch energy tax system. This has been implemented in 1996 and it's not very well known. I'm talking about the difficulties of this kind of tax and what kind of impacts they have on behavior, and what we have learned from implementing this kind of tax, because most of these discussions are linked to how difficult it is to implement these kind of taxes. And I'm explaining how you can move ahead with this kind of interesting experiences. Moreover, we have been able to evaluate this kind of tax recently and looking at so-called Pigouvian prices, so how the relationship is between the tax and the environmental damage. And it turns out that especially also air quality damage is very important relative to the climate change damage.
Within the workshop about carbon taxation and climate policies, my presentation has dealt with the micro methods and data. What's about? The idea is to have policy parameters in order to be able to use them for, say, the evaluation of ex ante or the evaluation of ex post. policies related to carbon taxation or related to the climate. So I have basically deal with problems with estimating causal effects for these parameters. So the first part of the presentation it's about examples where we estimate these parameters based on data, which can be from surveys or can be from registers or can be from the ideal situation, which is a combination of both. And the second part is how these parameters estimated from microdata can be used on micro simulation tools or can be used on other kind of econometric models which are intended to evaluate impacts of these policies. So summarizing, the message of my presentation is both on having the good data for estimating really causal effects of the policies, and then being able to use these parameters to evaluate the impacts of that policies.
My presentation today was titled Carbon Taxation in Computable General Equilibrium Models. CG models are a class of microeconomic models mostly used for ex-ante evaluations of specific economic policies, including carbon pricing. I started off by recalling the distinguishing characteristics of CG models and by outlining the evolution in their use since the 60s to our days. I talked about the strengths and the weaknesses of CG models and the choice of a model in relation to the specific research questions one wishes to address, especially in the context of carbon pricing. I briefly illustrated two important CG studies dealing with distributional effects of carbon pricing. And finally, we looked at a comparison of simulation results from a CG model and a macroeconometric model in the impact assessment of the 2030 Climate and Energy Policy Framework published by the European Commission.
My presentation today is about data and analytical methods using the data. As we know, recently large amounts of data have started to become available, for example, online, and I talk a bit about some of the ways that we can extract meaning from that data and how it could be used to set up climate policy in the future, potentially. I also talk a bit about modelling, mainly on an empirical basis, and particularly contrasting to the presentation of Stefano Verde, who very much comes from an optimization, general equilibrium perspective, whereas my presentation looks more at sort of empirical modelling approaches and how these could be used to assess climate policy and what some of the practical implications are in the results of that analysis.
So politicians are really worried about competitiveness effects of energy and carbon taxation. And economics tells us they should be, because there are detrimental effects of any pollution costs for competitiveness of firms. The funny thing is that as soon as you look at the actual evidence from a number of causal modern evaluation studies, you don't really find that effect, that detrimental effect on competitiveness in any of them. So what applied economics tells us is you really can't expect those detrimental effects on competitiveness for the policies in place today.
Hello, the topic of my presentation here at the workshop is distributional issues. As we all know, the benefits of taxation in terms of emissions reductions and reductions in consumption of fossil fuels are counteracted by costs, because taxation is money out of pocket, and such costs can be unevenly distributed across income or social brackets. And this can be an obstacle to the introduction of environmental tax reforms, complicating their political acceptability. There are different types of distributional impacts. For example, there are the distributional effects of taxation of energy goods, and there are the indirect effects of increases in energy prices on the prices of non-energy goods and services. This can be dubbed as the microeconomic distributional impacts as opposed to the macroeconomic distributional effects of energy taxation, like effects on the level of production, on wages, profits, employment, and investment. And finally, when the tax design also includes a revenue recycling mechanism, the different ways in which the fiscal revenues can be returned back to the households can each map into different distributional consequences, giving rise to the net distributional effects. All these effects can be considered either in isolation or jointly, and whether one considers them in isolation or jointly implies different methods of analysis. And so one has to be very careful when comparing different studies and when assessing results from those studies.
A major challenge to the more widespread use of environmental taxes is a concern that they would be regressive. That is, that they would put a higher burden on the poor than on the rich. New evidence for 21 OECD countries shows that taxes on transport fuels are not regressive, while taxes on electricity are. This tells us that if we were to introduce or to increase taxes on electricity, we might at the same time perhaps also want to think about compensatory measures. There are two things to consider when designing compensatory measures. First, environmental effectiveness needs to be assured. This can be done by providing relief either through the tax system or through the benefit system. Second, compensation needs to be well targeted. To determine which households are most effective, microsimulation models based on household budget data help a lot.
Carbon taxes and environmental taxes in general can be a contentious policy proposition. Despite evidence that suggests that environmental taxes can be an effective policy instrument. Now, this evidence has caused widespread support among economists for a carbon tax in some form. The public, however, remains skeptical, and this public opposition sometimes can prevent the implementation of a carbon tax. So I'm here at the workshop to discuss my research that I've done with my colleagues about this issue of public opposition to a carbon tax. So we've spent the last 3 years discussing and investigating the factors that can mitigate and magnify public opposition. And the hope is that if we understand the factors that drive opposition, we can design policies and communicate those policies in a more effective way to increase the likelihood of acceptance and implementation.
In my presentation, I was talking about the impact of the carbon tax on poorer households, or on the income distribution, and on possible ways in which the revenue from carbon taxes might be used, at least in part, to compensate those most badly affected. Typically, if we were to simulate the effects of a carbon tax, we would expect to see that poor households will pay relatively large amounts of the tax in relation to their incomes, and the burden of the tax therefore will be felt more heavily by poor households than by better off households. But the revenue that would be raised from a carbon tax gives the possibility of using some of that revenue to compensate households most badly affected. We can pay compensation in cash to poorer households, or we can use some of the revenue to improve insulation, energy efficiency, and in other ways to reduce the burden and severity of the higher energy prices on the poor.